right, welcome back. We're here on section 4.2 on multiplying matrices. Now back in 4.1, we multiplied matrices called scalar multiplication. That's where we take a number times the matrix, which really is just multiplying that number through all the entries. Well, multiplying two matrices is different. We're going to show you what that is. And sometimes you can multiply them, sometimes you can't. Let's talk about the rules. The rules are that if the rows of the first, the columns of the first, if they match the rows of the second, then you can multiply them, and the resulting matrix is an M by P. So it's the rows of the first by the columns of the second. Okay, that's what the result is going to be. Let me show you a few examples on that, and you can kind of see what we're talking about here. So if we're going to multiply A times B, you notice that we do have, it's a 2 by 3 matrix. This is a 3 by 4 matrix. We can multiply those together. Because the columns of the first do match the rows of the second. And then the resulting matrix, of course, is going to be a 2 by 4 matrix. Now this one, we can't multiply C times D because the columns do not match the rows. And so we can't do that, okay? So again, make sure that we go by the dimensions of the matrix. That'll let you know whether or not we can do it. If you can't do it, we'll say it's not defined, is what we'll say. All right, so a good thing to remember, kind of cheesy, I always say cheesy makes it easy. The car key is that the columns as the rows. Columns of A have to match rows of B, otherwise it won't even start. A little cheesy, but that's a good way to remember it. Okay, so a couple good quiz types questions. If A is a 3 by 4 matrix and B is a 4 by 2, well, let's just double check here. Let's see, do the columns here match here? That would be yes, and so the resulting matrix would be a 3 by 2 matrix. Remember, it's the rows by the columns. The inside tells you what they do, if you can do it. Okay, so there we go. We've got that. Okay, how about this one here? Let's see. Do the columns here match the rows here? Nope. So we would say it's not defined. You can just kind of do that with a little moot symbol, or say it doesn't exist, or it's not defined. That's kind of what we say. Okay. All right, so that's the easy way to tell. So now let's talk about whether or not we can find the product, if possible. Okay, so let's double check here. Looks like this matrix here is a 3 by 2, 3 row by 2 column, times X. This is going to be a 2 by 3. Okay, so this does match with that. The resulting matrix would be a 3 by 3 if we take W times X. Now, let's just kind of talk through how we would find this if we were doing it by hand. Okay, a 3 by 3 matrix is going to have 1, 2, 3, 4, 5, 6, 7, 8. It's going to have 9 entries. So the question might be, how do you get this entry right here? Well, what you would do is the address is the first row and the first column. So what you would do with taking W times X is that you'd take the first row here and you'd multiply it times the first column. So 3 times 4 is 12. Negative 2 times 5 is negative 10. We would add those together, and our entry there would be 2. All right. Well, what would happen? Let's pick another one here. Let's maybe pick this one right here. Again, that's going to be the second row, third column. So here's what we do. We would take the second row here times the third column. Well, we'd have negative 2 plus 0, so that would be a negative 2. I know when you're sitting there, I'm sure what you're thinking to yourself is, oh my goodness sakes, okay, that would be quite a bit of a process. Lots of places to make mistakes and do that, and you're absolutely right. So what we can do then, let's go back here. We can get our friend, and your friend and mine. Let's grab our graphing calculator. And let's go ahead now. What we're going to do here is, let's slide this over here so we can see a little better. We're going to put these matrices in. I'm going to call it A and B is what I'm going to call it. So what we're going to do is we're going to hit second, and then we're going to hit the matrix button that's right here. All right, and what we're going to do is we're going to go over here to edit. And we're going to edit matrix A. Let's do that. And so we have to tell it what type of matrix is it. Well, and this is the nice part, even if you type it in wrong and screwed up, you'll see that it's not right. This is a 3. Let's go enter. Oopsie. I better go back. Oh, boy. All right, 3 by, well, it's a 3 by 2. let's delete that. Okay, let's just go 3. There we go. Enter, enter, there we go. All right, so let's put the numbers in. We're just going to type in a 3, enter, then we have to go -2. Make sure that you hit this negative button, -2. All right, and hit enter after each one there, and then we're going to go 1, hit enter, and then 0's already there. Then we got 2, and then let's make sure we hit -1. Okay, so we've got that one stored in there. Let's hit enter. All right, so I'll double check the numbers, make sure they're right. There are. All right, so let's go ahead and put in matrix X, which we're going to call matrix B, just because we don't know how to scroll all the way down, but we'll come over here. We'll hit the arrows over. We'll go over to edit, but this time we're going to edit matrix B. So let's put that in there. And this time looks like we have 2 rows by 3 columns. And there we go. We have a 4, a 7. Let's type in, make sure to hit that negative here, -2. And then we go 5, 1, and then of course -1. And hit the enter. Okay. All right, so we've got those stored. So we're going to go up here. We're going to hit second quit. I guess hit mode. I want to hit second quit. Okay, second quit. There we go. All right, so now we go second, go to matrix. Let's name matrix A. And the order in which you do it is important. We're going to go times, and then we're going to go matrix B. Let's name matrix B. Let's see, we got to scooch down just to where it is. And then we hit enter. Bada bing, bada boom, there it is. So again, we can use the calculator for matrix multiplication. I would certainly encourage you to do that. And there you go, there's your answer. And again, if you try to do B times A, you'd get an entirely different type of matrix. So make sure you do it in there in that order. So again, some tricks of the trade with the calculator, nice tool to have, of course, as we work through it. Okay. All right, now let's see if we can take matrix X times Y. Now again, this is a 2 by 3 times a 2 by 2. We would say no, because the columns 3 does not match the rows here 2. Now, if you did it on the calculator and you typed it in and you tried to do it, it would say error, which indicates that it can't be done. It's undefined. Okay. B times C, could we do that one? Well, let's see. We have a 3 times 3 by 2 times a 2 by 2. Yeah, we could. I'll let you type that one in, try it if you want to, but again, just double check first if you can do it. All right. Now, what a square matrix is one that has the same number of rows as columns. So n by n, m by m, whatever you want to call it, it's the same thing. And the main diagonal is where we go from the upper left to the lower right. Okay. And so we talk about the multiplicative identity, just has all ones there. All right. Now, because square matrices can be multiplied by themselves any number of times, you can find powers of those square matrices. All right. Can you find the square of a non-square matrix? In other words, if matrix A was 2 by 2, we know that we could do it. But if it was 2 by 3, well, the answer is no, because if you take a 2 by 3 times a 2 by 3, the columns don't match the rows. So the only ones that we can really find powers of, we can take it squared to the third power, to the fourth power, have to be square matrices. So they have to either be 2 by 2, 3 by 3, 4 by 4. So we could certainly put these in the calculator, and we could do that. Now, what some people think, and incorrectly, is that when you square a matrix, that you just square the numbers inside, and that's not true. Okay, remember, it's matrix multiplication is a little different. So what you want to do is put the matrix in. In this case, we put in matrix Q. And then what you want to do then is go ahead and use that caret key to the second power. That's how you square it. Now, if you wanted it to the third power, you just have to put a 3 there, and it would find the answers for you. As you can tell and see there that, yes, indeed, it isn't as simple as just squaring each number. No, that's not what you do. Okay, so don't make that mistake. Actually put it in and actually square it is what we want to do. Okay, so there's some matrix multiplication. Again, deciding whether or not you can multiply. Remember, the columns of the first have to match the rows of the second. So remember, A times B is not necessarily going to be equal to B times A. In fact, you might not even be able to do B times A in some cases. So be careful of that. And then make sure that if you take the square or the cube of a matrix, it's got to be square. So it's got to be 2 by 2 or 3 by 3 or 4 by 4. And again, you can put those in the calculator. Again, go back and take a look if you want to remember how to do that. So, all right, so that is multiplying matrices 4-2. Until next time, I'm Mr. Boone.